Right, well, I'll kick off. So very good morning and welcome to everyone. My name is Martin Sweeting. I'm the Director of the Fair Space Hub and here today at Surrey. As was mentioned by Carsten, here at Surrey we're not expecting any fire alarms, so if there is a fire alarm, please go out, which is pretty obvious. Leave out the way you came in and meet outside. I'm not quite sure where the shortest route to the loos are, but I'm sure there's some signs which will direct you should you need that. Anyway, I'd like to, of course, to say hello this morning to colleagues in Edinburgh and Imperial. Carsten, are you there? Hi, Carsten.
Hi.
But he wasn't there. Hi, and Setu, are you there? In Setu?
It's here.
Yeah, great. Anyway, good to have you on.
From Edinburgh.
Great, thanks. Good to hear you from Edinburgh. And of course, I'd like to say hi to everybody else who's joining us online. So today, we want to demonstrate the achievements that have been developed by our research team over the 5 years of the Fair Space project. So thank you all very much for joining us today. In fact, we are approaching now the culmination of Fair Space program, and today's showcase event follows a very successful summit that was organised and held in Manchester about a month ago. And the aim today is to demonstrate and prompt discussion around what has been achieved by the Hub over the course of the last 5 years. So we will begin today by inviting some of our industry and government advisors to share their perspective on space, robotics and autonomous systems, and indeed their support for Fair Space over the years, and what they might hope to see leading out of Fair Space for the years ahead. We will then move on to the demonstrations that are the centre of the agenda today, followed by a number of research presentations, and then finally an open question and answer session to explore research priorities for the future. With contributions of 5 research teams and over 30 industry partners, Fair Space has advanced robotic capabilities in space across 5 core areas of research: sensing and perception, mobility and mechanisms, autonomy and AI, human robotic interaction, and of course bringing all of that glued together with systems engineering. And we'll be touching on all of those today as they represent a remarkable effort that pushes the boundaries of AI and robotics for space, built on a research-based expertise, but also the strength of collaboration which emerges from such a hub program. So we're now also looking ahead to unlock the value of the community that's been established by Fair Space and its potential for contributing into the UK industrial strategy. So we have therefore asked all the researchers today to share their thoughts on the next steps in the afternoon sessions, and to, of course, participate in the Q&A session at the end, where we invite you all to submit your questions to them. You can submit your questions on Slido by scanning the QR code, which will miraculously appear at some point on the screens. For those that are online, please, we really would like to have your questions in the chat function, and then we'll try to bring all of those together and make sure that, say, we'll triage them and then see if we can address them in the Q&A session. For all of those that are at the various sites and who can, we really welcome you to stay on for the reception afterwards, and we can have a little bit more of an informal discussion on the topics. So that's by way of introduction, and thank you everybody for participating today. And it leads on seamlessly into the introductory panel. So we're going to commence today's program with a panel discussion on the role of robotics and AI in space systems, both now and for the future, and in particular the relevance of the academic industry collaboration that's been established by FairSpace. So I'm very pleased that on the panel, I have with me here in person, in 3D, I have Dan Jones, who is the Technology Cluster Manager at the UK Space Agency, and also has been chair of the FairSpace International Advisory Board. And it's an opportunity to thank Dan for his contribution and efforts over the time in that role. Virtually, I hope, we have Sue Horn, who's head of space exploration at the UK Space Agency and a member of the FairSpace Independent Steering Committee, and Richard Holdaway, who's chairman and chief executive of Cambridge Space Systems and also chair of the FairSpace Independent Steering Group or Steering Committee. So I'd like to start off by inviting, first of all, Dan to come up and sit with me, and hopefully we have Sue and Richard somewhere in the ether, and they will magically appear, I hope. We'll just take a pause whilst they magically appear. Any sign of Sue and Richard? Otherwise, it'll be Dan and I, and we've got plenty to talk about, but it would be nice to have them as well. Anyway, I will sit here, and whilst we get Sue and Richard connected, Dan, you've been, let's say, chair of the International Steering Committee on FairSpace, and I just wonder, over the 5 years, what are your perceptions of how the hub has developed, and also, the increasing role and importance of space robotics? But feel free to talk about anything.
Well, it's been an interesting journey. I think it's safe to say over the past 5 years, the background and the context in which the hub has operated has changed. Not least from the perspective of the UK Space Agency and what's been rumbling away in the background with respect to government. We've exited the EU in that time, which has changed certain things. And here we are right at the end of the FairSpace Hub program, and there's a war on, which is having huge implications for, well, all sorts of different things, and that includes space as well. So the background has changed a lot, and there have been internal challenges within the hub as well. But what's struck me is the resilience and the fortitude of the researchers and of you and your management team in running the hub, and in bringing together a portfolio of technologies and demonstrators, which we'll see today, that is really worthwhile and is worth the spend that has come from the agency and from EPS. Well, I can't speak for EPSRC, but I think it's safe to say that the program has been a success, and it's gone through peaks and troughs of difficulties and successes. But I think it's ended up at a very worthwhile place, and I think congratulations should be given to you and to the whole team in that respect. How things have changed. Let's look at a little bit more high resolution at the picture in the background, how things have changed. Well, in 2017, when the hub started, I think it's fair to say that space robotics, certainly as a commercial market, was pretty much non-existent. Okay, and we were very, very pre-commercial at that stage. There has been an idea rumbling around the community that robotics could be used commercially. And they've been used institutionally for some time now. I don't think we need to go into the details, but you can look at the International Space Station and Canadarm and things like that. But commercially, because of the costs involved in institutional missions and running robotics, and the huge amount of redundancy that's required in the system, it's been prohibitive to commercialize the technology. Now, fast forward 5 years to where we are now, we're still in that pre-commercial stage, but all of a sudden we're very close to some real demonstrators showing that the technology does work, and people are getting a little bit more interested now. I mean, it was a niche sport, I think, 5 years ago, space robotics. but EPSRC and well, certainly the agency saw there was something in it and something worth investing in. And now I think we can see that risk taking, and it is a risk taking approach, has borne fruit, because now suddenly everybody is interested, and the UK has got itself into a position where we can be world leading, where we can be at the cutting edge of these technologies if we continue to have the wherewithal to bring them through that process of demonstration in flight, not just in the lab as we'll see today, but in flight. And the UK Space Agency is leading efforts on that to make sure that these technologies are taken into space and shown. There's a lot more appetite for that now, and I think the hub has helped position the UK amongst other programs. It's helped to position the UK very nicely for the next period of activity, which will be demonstration of the building block technologies, some of which we see today, and also then qualification and mission design. So yeah, I think that's probably where we are.
I think you put your finger on it, because over the last 5 years, one of the things that has changed, I think, quite dramatically, is the role of the private sector in space, particularly at the moment in space launch, of course. But we're seeing a plethora of startups that are addressing a number of applications from space, including those that now start to utilize robotics. So in-orbit debris removal, some research that was done several years ago now is, we can see, beginning to emerge into the commercial private sector. Companies like Astroscale and ClearSpace looking at commercial programs for space debris mitigation or space debris removal. So I think clearly there's been quite a shift, both in the move of growth of the private sector in space, the application of robotics to commercial application. Of course, it's true to say, space robotics isn't new. We've had robots in terms of planetary landers for decades of one sort and the other. And indeed, just you can talk about remote sensing spacecraft as robots in low Earth orbit sensing the Earth. But what we're looking at here, I think, is a different step change in terms of space robotics, where we're considering applications for in-orbit servicing, in-orbit manufacturing, and space power, which is in-orbit space power, which is going to require robotic support. So, I think there's been a dramatic shift in the emphasis in space towards growth of the private sector, and then opportunities for space robotics, which 10 years ago were probably science fiction, 5 years ago were wishful thinking, but now actually they're sort of just almost at the end of our
it's interesting. I think the point about the private sector growth, we have Sue online.
Sue, welcome, Sue.
The point about private sector growth is really pertinent, because I've been working on European Union funded programs for the last 10 years or so in writing technology roadmaps and developing technologies for space robotics and space robotic markets. And the problem at the beginning was, or the risk at the beginning was, that the private sector, which was smaller than it is now, wouldn't want to invest, because the returns on the investment were essentially nil. And the reason for that is because the market didn't exist. It was a punt. Now there are more players in the market entering, and I think that's down to a change in philosophy. It's the realization that the market is coming, and so there is an opportunity coming, but it's also down to the approach of the technologies. There is clearly a drive towards modularity, open source technologies that are accessible via paying of a subscription or licensing, and may not be inhibited by intellectual property rights in the same way that they would have been 10 years ago, and using, in the context of the largest space market, which will be SATCOMs, that business model isn't necessarily applicable to the market that will be defined as, let's say, in-orbit servicing. It's a different market space, and companies are realizing that now. So yeah, that's a pertinent point. And I expect, as modular technologies are proven to work and the regulation is there to back it up, I think we'll see a host of new players entering the market who are able to operate at short notice with agility, take advantage of the cost reductions and the improvements in mass fabrication and mass manufacturability, digitalization, and bespoke bespoke design.
Yeah, but before I bring Sue in, just a comment to add to that, because I think you put your finger on it. The issues actually now, when you look at some of the businesses that are looking to exploit space robotics, it's not so much the fact of the return on the investment as the time it's going to take for that return to come.
Indeed.
And I think we're seeing a shift now, particularly this is, I think, quite apparent in space-generated power, where technically it's a challenge, that's for sure, but financially the project is such a long term before you get the returns. It's a real financial hurdle rather than a major technical hurdle.
Well, I think just to sort of zoom back out a little bit and look at the holistic picture, the point about space-based power is correct. It's very long term. The technology isn't there. There's a push for it within government. It's certainly a topic that's being bounced around with some enthusiasm. One of the hot topics at the moment, for obvious reasons, because what's happening in Ukraine is energy security. And so all of a sudden, if you can have a piece of infrastructure that provides energy security at low cost once it's up and running, then it becomes extremely attractive.
And of course, that's something
it requires that long-term vision.
It's long-term vision, and it also will be fundamentally dependent on robotics, because the only way you'll be able to implement such a program is through robotic assembly and
for the assembly, the maintenance. Yeah.
And the other point is, of course, we will need, I don't want to expand on it, but the governance structure around space robotics is going to be something that's going to require quite a lot of work. Anyway, I'm very pleased to see that we're joined by Sue Horn, and Richard in a barn somewhere. Sue, perhaps I could invite you to contribute any thoughts you might have on the topic. I hope you've been able to hear our discussion thus far.
I had problems entering, so I missed the first verse. So I think Dan's probably covered a lot of what I would have said. And I think there are huge commonalities with robotics as a whole. And I've worked closely with the nuclear power industry, the mining industry, and all those industries that are working in extreme environments. I think there is a lot of commonality, and that initial research can cover a lot of sectors. I think the constraints specifically on space, which other areas don't have, the power issues, the computing power that are on some of these spacecraft isn't what people are used to, and they assume there's more computing power on board. And also with the sort of Mars programs and things, the communication issues, the latency. If you go, and that's why you need the robotics and autonomous systems. But I think the first time that humans go to Mars, they will actually only be orbiting and probably be powering systems on Mars from orbiting before landing. I think looking to the moon, that's very interesting, because I think the next bit of space exploration, you're going to have far more human-robot interaction. The preparing of the base on the moon is going to be robotic. So I'm going to step back in time. Construction on the moon, different type of construction techniques. But I think my first job in the research councils was robotics in the construction industry. So I'm going back to that, and also sort of in situ resource utilization, doing all that robotically. So the problem with exploration is the market, and I would have said the market is more around the in-orbit servicing, in-orbit construction. The lunar, in the first instance, I think will be government funded, although it could be different ways, a more commercial way of funding it, buying a service. But I think the majority of the funding will emanate from governments and institutions, and then potentially go to a market. But I think robotics and autonomous systems, looking at what the UK Space Agency is doing, it's underpinning a lot of our technologies. And that underpinning means that perhaps it doesn't get highlighted as much as it should be.
Yeah, thank you. Yeah, I think the role of the private sector in exploration is going to be very interesting. Clearly the private sector is going to provide many of the tools for this, but at the same time, whether they will have the opportunity to do sort of public-private partnership type of financing will remain to be seen. And I think moving to a service provision rather than a procurement directly is another area. And we've seen ESA take the first steps in this, not in robotics, but in lunar communication services. And I think it's quite possible it may translate across to robotics later. Richard, you vanished. Hopefully you will reappear, Richard, if you can hear us.
Yeah, I can hear you fine, Martin. In fact, Sue and I joined this whole conversation 3/4 of an hour ago, but we had a great conversation between ourselves because the link wouldn't actually let us in. So we've solved most of the problems of the world already, and that was before you even got started.
Do you have a synopsis?
No. But what I will do is first of all, just repeat something that Dan said and Sue commented on, which is, it has been a very difficult time for Fairspace. And all credit to the whole team, the PIs, the management team, the administrative team, and indeed the funding partners who have all gone above and beyond to try and get us through COVID, as well as some other difficulties. And I'm going to embarrass you, Martin, and say a big congratulations for you when you stepped in to take over running the hub, because I think if you hadn't have done that at the time that you did, even though you had 101 other things to do, I think we wouldn't be having a conversation now. I think Fairspace would have finished a long time ago. But it has been a good success. There's been a lot of progress through all the organisations involved. And one of the, I think, key things is that the timing now really is right to expand on everything that's been done, both with Fairspace and many other activities that are going on in space AI and robotics, because we've got to make darn sure that this is the end of the beginning, not the beginning of the end. And government in general has robotics and AI as a very important part of its strategy. And that's particularly true and timely for space AI and robotics. And there are a number of initiatives that most of us know that are going on at the moment, not just in space AI, but in other sectors where now we're beginning to join up with the sectors. And Sue mentioned the nuclear industry, and there are some initiatives that are being led at Culham that you and I, Martin, and Dan are aware of and working on, to look at the commonalities of systems where you've got a dangerous environment, which nuclear and space has, and the need for remote action on robotics, which space and nuclear has. So there are timely things going on there. The Catapult is leading a very important initiative, which involves industry as well, for a bid to government, which essentially is for looking at commercializing in-orbit servicing and mission operations. And actually that links in with what Culham are leading as well, which is on a sort of proving ground, a test lab, testing out things not at the individual subsystem level, but at the mission level, which really is important. And if we can get this right, I mean, that's the whole community. So whoever is listening and whoever is watching today, of what's been going on with fair space. It's much wider than fair space, but it's really up to us all to take advantage now of the opportunities and persuade industry to really take part as well, because the industry at the end of the day is the ones that will benefit. And there are huge, I'm sure, potential there for the UK to be true world leaders in things like mission operations and in-orbit servicing. So I think that points us towards the way forward, and we've got to take advantage of it now. If we don't take advantage of it now, we're never going to be in such a good position again.
Can I make an addendum to that comment, and to
Absolutely,
Sue's
yeah.
as well? You both mentioned other sectors and working with other sectors. The nuclear sector came up from Richard and from Sue, and there's something instructive there. There's certainly possibilities for space and nuclear industries to work together, and I think that we should be pushing that. And it's an example of where government can spend money smartly in trying to hit two birds with one stone, for example. But I think industry needs to pay attention to things like that as well, because when we're operating in a pre-commercial market, industry still needs to make itself self-sufficient. And a good example is that of Reaction Engines, who have developed the Sabre, the synthetic air-breathing rocket engine, which is not likely to be in commercial circulation for another 10 years. But they've been able to grow their business from around 40 people 7 to 10 years ago, something like that, to around 200 people now. And that's through developing the technology, but it's also through establishing commercial links and commercial exploitation routes with existing markets. So they have their pre-cooling engine technology, which is remarkable. It takes fuel, superheated air coming in at 3,000 degrees and cools it to ambient room temperature, around 30 degrees centigrade, in a matter of seconds, less than a second, I believe. And they've managed to find routes of exploitation with aerospace and defense, and with the energy sector as well, for harvesting heat that would otherwise be lost and using that to power more energy utilities. So it's something that industry needs to pay attention to. With robotics, there are clear terrestrial applications for some of these technologies. Industry needs to be smart if it wants to be self-sufficient. Government, I'm on panels at the agency where we have to look at administering grants and giving green lights to certain funding packages. And the ones who are smart about it always look beyond the space markets, especially when we're in a pre-commercial phase. So you have to look at what commercial exploitation routes exist on Earth, and you have to be talking to them and bringing them into the conversations. It's absolutely critical, because some of this stuff isn't going to be in the commercial, the market isn't going to be fully commercialized for some time. And there are technological reasons around that. There are regulatory and legislative reasons around that as well. But you have to have one eye on what's happening on the ground also.
Yeah, thank you, Dan. Richard, thank you for your kind comments, but I must react and say that all the work has been done by the PIs and the research teams. My job has been rather like the conductor of the orchestra, and I often suspect that if the conductor fell through the floor, the orchestra would just keep on playing perfectly adequately without him. And I suspect it is exactly the same thing here. So,
not true, by the way.
However,
have you seen an orchestra playing without a conductor? There are some good YouTube videos.
Oh, really? Okay. Perhaps I better look at that before I use that again. Nevertheless, I think there's another point that Richard raised, which I think is worth just commenting on, and that is we're now at a point where I think space robotics is sort of emerging from the undergrowth, and there are a number of groups, from different application technologies and industries sort of looking at this. And I think we're in the danger, if we're not careful, of having a number of rather disparate groups who are all sort of planning much the same thing. And therefore, I think it's a fairly urgent need to bring this all together so that from a UK perspective, we have a clear picture of all the various aspects of this, and of course the links into the different industries. So I think, over the next few months, I think there's an opportunity for us to perhaps bring these various groups together and just sort of put all our components on the table and say, right, this is what we're doing, and make sure that when we do make pitches into government for funding, and the private sector go to their investors for funding, that there is a coherent story, even if there are sort of hotspots of activity which are focusing on particular areas. And this is perhaps an opportunity for me just to mention that the Royal Society is carrying a study looking at, it's called A Perspective on Space, looking right the way across all aspects of space for 2050. But one key pillar of this is going to be the role of space robotics in developing the space economy beyond Earth. Anyway, let's see. Sue and Richard, anything else you'd like to chip in on? So wave your hands if Richard's twitching.
Yeah, so just a couple of follow-ups to your follow-ups. I mean, we've mentioned nuclear, but of course, there is plenty of potential to work with the usual other sectors, agriculture, medical, transport, defence, and plenty of others. But I think when we do that, I'd like to put a slightly different spin to what Dan was saying about working with industry. We actually need to help industry. I mean, yes, of course, industry does need to take the whole thing seriously and so on, but industry needs help with that, and it's up to us to do that. It's part of the communications process that we often talk about. And communication is a contact sport, and it's I think important that we're all involved in that, making it clear just what potential there is for this type of work. And the other final thing, just to remember what I think about it, is we're not world leaders in robotics in this country, in almost any sense, but we're not far behind. But what it does mean is that we should be looking very seriously at the 2 or 3 countries that are, US obviously, but there are some ITAR issues there. But in particular, the Canadians have been world leaders in robotics for a very long time. That's why they've been doing so much work on space station. And there are a number of groups there that now it is very timely for the UK community to work with. And as you've mentioned yourself in the past, Martin, the Japanese as well, who of course are world renowned for doing very clever stuff in robotics, and not just walking robots that bark and flip and can do backflips, but they can do a lot of very, very serious stuff as well. So I think the whole of our community, with the help of the agency and Innovate UK and so on, really need to think seriously or more seriously about working with other countries. We've got the problem in this country, of course, that we always try and keep IP very close to our chests, whereas other countries tend to share IP more generously. And that in part is the background to the Space Applications Catapult. And I think we need to follow that model as well.
And I think, Richard, the point you make is that the UK can actually, I think, establish some world-leading expertise in certain spectral lines of technology, and particularly in this case, robotics. We're not going to be a world leader across the whole patch, but I think if we can identify the real areas where we can contribute internationally uniquely and then focus on those, then we will have a major seat at the table in what in the future are going to be very large international programs. There's no doubt we won't be able to do all of them. And Sue, maybe we have a few minutes left, but maybe Sue, you could comment on what you see perhaps as the requirement for robotics in space exploration that you would see coming up over the horizon, not the stuff that we're doing at the moment, but what are going to be the real drivers that you're going to need to support space exploration?
I think, right. And just before I answer that, I agree with Richard. We really need to be clever about what we're doing. You really need to engage industry at an early stage, and certainly in exploration, you need to understand the international playing field, because we can't do everything, and some things have already been carved out by certain players, or NASA won't actually want to do it themselves and won't accept contributions in those areas. So I think it's really important to do that engagement. So what research is done is going down the right routes and is going to be picked up by industry quickly and is supporting what industry are doing. So I think, in addition to the sort of things that Dan said, I think for the UK, budget depending, there are really clever things that we have got in the UK on in situ resource utilisation and producing oxygen from lunar regoliths. That at the moment is not automated at all. And that's going to be one of the big problems to get that in, is that automation. But this is a process that is actually used on Earth in mining to extract titanium and various metals with oxygen as the byproduct. That process on Earth isn't automated. So trying to work together, we get synergies and help back on Earth to do things better here as well. In the long run, it's going to be Mars. The aim is to have humans on Mars. That is an enormous problem. You're going to need to prepare bases for humans on Mars, and I'm not talking about sort of permanent bases, but it's a 500-day round trip, 500 days to do a round trip to Mars. You will be spending some time on that on Mars. Things are going to have to be prepared in advance, and certainly on the Moon, the human interaction is going to be important. But looking to the long future and Mars, that is going to be government funded. That there is no profit there. And the clever thing is working out what the spin outs and where these technologies can be applied either in commercial space or back on Earth.
Thank you, Sue. I mean, at the risk of using another analogy, which would be shot down immediately, I think that there's a lesson to be learned. The UK is a small economy. We have a relatively small budgets for space and technology compared to many of our international competitors. So we have to choose those spectral lines of expertise to be very carefully so that we get our return on the investments that government and industry makes. And if you go back to the gold rush in the 1880s or whenever it was, an awful lot of people rushed out to California to dig for gold. Some people found it. The vast majority of people didn't. But the people who made the money were those that provided the railways and those that provided the shovels and the hotels and various other entertainments, which I won't elaborate on. And those are the people that made the money. And I think this is a role for the UK. We need to look at where are the services that the big international projects are going to require support, and where do we have unique capabilities which we could pop in and do that. The UK is very strong on communications, so I think providing communication services, Vodafone around the moon type of thing, to provide the infrastructure to support the huge investments that will go on to the lunar and later Mars exploration is an area for the UK. Where are the same spectral lines for robotics where we can contribute? Maybe it's in situ resource utilization. Maybe there's some other areas, teaming up with the Canadians, teaming up with the Japanese in order to together provide something that's really unique. We have just a couple of minutes left, so I'd like to whip round and give Dan, Sue and Richard the opportunity for last words. For those that have got questions, we're going to have a Q&A session at the end, so don't forget your questions. Write them down and send them in on the chat or send them in on Sligo, and we'll bring them all together and try and address them at the end. So Dan, over to you, and then a minute or two.
Okay, I'll be rapid. things that we're good at. We're very good at software engineering and autonomous navigation. I think we should be pushing that. On its own, that doesn't really mean a lot in robotics unless you can embody it. So I think that one of the areas that we need to push quite hard is the collation or establishment of testing facilities in the UK. Now, we do have some really good testing facilities in the UK. They're not always very visible. They're not always all known. So I think they need to be categorized and maybe not centralized in the sense that the government farms out the service, but they need to be catalogued and understood by the community. So we need that, and we need more embodiment in physical robotics, because I think we're world leading when it comes to the software side, and we do lag behind countries such as Japan and Canada when it comes to actually embodying them in mechatronic systems. So there's that. Other areas where we're a powerhouse, not technologically, but insurance and regulation. We're very good at both of those things with respect to space, and we need to bring those guys into the conversation as well. But that's something else.
Absolutely. Sue,
Oh,
any last comments?
that has taken words out of my mouth. So I think my last comments are, it has been a pleasure actually to see how this is developed from the very early, before First Space, there was a previous program on AI, and I think now we can actually see within orbit servicing, but potentially within orbit manufacturing, that there are real places where the UK can make a difference. I think another thing to think about is where we are now with Brexit, and where government is trying to develop new areas of partnership and collaboration, and sort of Canada and Australia are high on that list. So there are opportunities there, and we have a lot of commonalities with these countries in how we work.
Thank you, Sue. Richard?
Just finally and quickly, and I was thinking while you were giving your initial talk, Martin, this morning, one of the things we need to do more of in general in space, and particularly in AI and robotics, is to think the unthinkable. To think laterally about where the additional applications are that we can spin off. I did a live radio show in the States a couple of weeks ago, and the presenter asked me what wonderful things JWST is going to come up with, and I said, well, it'll come up with one or two things we can think about, but most of the amazing things it comes up with, we have no idea what they are at the moment. And that's the beauty of science and how it leads into technology, that you just never know what's around the corner. But it needs innovative thinking, and anything that government can do to persuade its review panels to go for innovative science and particularly innovative technology and creative solutions is without a doubt the way forward. And the UK can be very, very good at that.
Yeah, thank you. I think you're absolutely right. We can never really predict what the future will bring us. And in fact, if you go back and think 10, 15, perhaps 20 years ago, read science fiction, look at the science fiction movies and so forth. Star Trek springs to mind, but there are others. A number of those gadgets that they had have materialized, but who thought of apps? Nobody expected that apps on our smartphone would run our lives for us. This was something completely unexpected, and of course there are many other examples. So we have no idea what the future.
Very quickly, the App Store phenomenon is a really apt analogy for space robotics, because it's based on a principle of having a common source code, which is available and licensable to any developer. Anybody can get hold of the source code, and then they can develop an application in whatever field they want to at low cost, and they can offer it at low cost or even free to the consumer. And if you have that common technological building blocks in place for robotics, whether it's robotic arms, autonomous navigation systems, data fusion, sensor suites, plug and play, all of those different things, you can enable the same sort of
And a
growth
huge economy
in the
I mean,
market.
and
It's
it's
potentially
a huge
huge.
economy.
Yeah.
Yes,
So
huge
it's a
economy.
really good analogy.
Right. Well, we're just a minute or two beyond our allotted time. So I'd like to thank Dan and Sue and Richard for having a very entertaining and interesting discussion.